engineer with a strong interest in building clean and maintainable code base. With hands-on experience across the full development lifecycle from planning and design to implementation and deployment, he specializes in developing clean performance code and automating robust infrastructure workflows. So thank God, you can come up right now and do like a brief introduction if you want to add to what I just said, and you can take it up from there.
All right. Thank you. Give me a moment to share my screen and my video as well.
Yes.
Okay. Good evening, everyone. So, she has basically said it all. I am, thank God, and I'm a software developer / DevOps engineer. Please let me know my screen is up.
Yes, it is.
Okay. So tonight we'll be talking about code quality as a culture, shifting quality left, and in other words, we are basically going to be looking at how to build reliable systems by catching the bugs before they reach the cloud, our production environment. Who is speaking? I am God Chibugwum Obobo, and I have the confidence to stand before you today because, like I've said, I'm a software developer and DevOps engineer, and I do have repeatable experience across the entire software development cycle. That's my portfolio there. You can scan the QR code if you want to get to know me better. And I hope with these few points I've managed to convince you and not to confuse you that I am qualified to be here today. So let's dive right in. So software development lifecycle, the software development lifecycle, like as we may know it involves these few steps. So there is a requirement analysis stage where the stakeholders look into the problem that's being solved by that project, and kind of try to get what it takes to handle the project from start to finish. And then there's a feasibility study where you kind of consider the possibility of actually getting the project done. Then there is the design phase where the bits and pieces of what makes up the system, it's there is a plan as to how to arrange them and put them in place so that for optimal results, right? And then there's the development phase, and then eventually after development you begin to test, and finally you deploy. I mean, that's the typical stages as we used to know it, but things have been evolved, especially with the advent of the current agile setup, where agile is known for reiteration. So you do something, you try it out, there needed changes, you go back, you do it again. As compared to this is usually done in a waterfall setting. So, but in an agile setting, you very typically do something, try it out, go back, fix it, come bring it out again, and the cycle continues. And basically, what I'm here to talk about today, and what I mean by shift left, is shifting the testing phase of this cycle left, basically putting it in every other instead of having it at the last point before deployment, you are putting it in between every other stage and making sure that by the time you get to deployment, you would have caught a lot of issues that would have come up in production. And now, in words, shift left is the process of taking a step that's part of the value stream of software development and moving it up the timeline. Shift left testing means moving validation and quality checks to the earlier stages in the software development process. In practice, it often means shifting regression testing closer to the design and development phases rather than waiting for a traditional QA cycle. The target, like I've said, is actually just to catch the issues before they actually leave the developer's machine rather than in production. So I mean, it's oftentimes we hear stories or situations where um you know, something happens to a system and then it crashes, and there's a lot of chaos here and there about, oh, maybe it was done intentionally or it wasn't. But the point I'm trying to make is production systems break a lot of times, but this is kind of a way to mitigate that. Now, what are the benefits? We're looking at faster delivery, because you're not trying to get everything right the first time. You actually hit the markets, in a shorter um, length of time. And there's also an improved security structure, because you've reiterated over it several times. And I mean, if you've done something more than once or twice, there is less likelihood for you to have missed an issue, or an impending issue, right? And then reduced costs. Imagine a situation where you're building a house, and then the bricklayers have laid maybe like the first decking, and then you realize that there is a wall that is not really standing straight. And I mean, it's a structural nightmare, because that wall could fall at any time and the whole building would collapse, or maybe the pillars and the whole building would collapse. And that's very risky. At that point, you are faced with two options: either you tear down the whole thing and start afresh, or you just go with the risk. But I mean, how many people would want to live in a building that is not standing upright? So that's kind of a way to explain how this reduces cost, because if while the bricklayers were laying, they were using the proper tools, and they were actually checking and considering the straightness of the walls or the pillars they are building, then they will not get to that level, and then eventually realize that they've messed up things, and there will be no need for tearing down and starting afresh and all of that. Improved security integration, like I mentioned. If you keep testing what you're building at every phase, at every time you are integrating um, new code to old ones, you find that at the end, or at the time where you want to move to production, you would have probably covered all of the security issues that that product might face. Then there is greater business success. I mean, if costs are reduced, that means there is greater margin for profits. There is literally no better way to explain that. And then, how can you start today? What can you do as a software developer? What can you integrate in your workflow as a developer, in to achieve um, a better security posture, to integrate testing right into your workflow, right into your development? And one of those things is automated testing. Yes, you could go around and say, I'm not a tester. I'm not a QA/QC engineer. I don't do this. I don't do that. But the truth is, the responsibility of the products we build lies on everyone. It lies on the whole team, on not just on the testers, not just on the backend developers or the front end developers, or the system admin guys, or it's not just a particular person thing. It's a team. We are working as a team to achieve one thing. So it's best if we can, play the game however best we know how to play it, to get the optimal results. So automated testing is one of the things, as I believe every developer should know how to do. So with frameworks like Playwright, you can actually write end-to-end tests to you know test the gamut of features you have in your product. Each time you maybe open a pull request, or you merge new code to the already existing ones. And what this does is it actually confirms to you that you haven't broken any older feature with the new one you just added. Or maybe you made a bug fix and it's supposed to fix a particular feature, but then because of the way you implemented it is breaking another. Having these tests would make sure that whichever feature you've completed and have tests for, would make sure that that feature doesn't break in the future. Also, there is something called regression testing, and this is where um, a bug is caught, an edge case most likely is caught in production, right? And then you now have to write a test to cover that particular edge case. So just to make sure that it doesn't happen again, that's called regression testing. So that's another way you can use automated testing to your benefits, right? And automated testing is really a good thing. There is Playwright, there is Cypress, and a whole other bunch of frameworks you could use. There is also unit testing with tools like Jest, PyTest, and the rest of them. I don't have them in my slides, but I'm sure you can very easily find those things on Google if you're interested. And then quality gates. Look at quality gates as well, gates, like the name implies, gates are basically a demarcation that divides two separate places, right? And then controls access from one of either sides. So in this case, quality gates would be um, a certain threshold or a certain quality that new code has to meet for it to be able to allow for it to be allowed to be integrated to the old code or the already existing code. And then we can use tools like GitHub Actions or Jenkins for linting. I mean, linting, formatting, and builds and all of that are ways for us to test that the new code coming in meets the requirements for it to be accepted and be part of the already existing code. So you could use CI/CD tools like GitHub Actions, Circle CI, and I think GitLab CI. So you can use those tools to perform automated linting. And linting basically looks at making sure that the new code meets certain structural and technical criteria. And formatting looks at how you arrange the code, things like length of character per line and stuff like that. And then there is multi-stage builds or builds in general. So there are also situations where a developer writes code and pushes it to production, but then the code gets to the point of deployment and it's unable to build because of maybe a type error or syntax error or something of that nature. And then it now becomes a problem because the developer has to go back and trace what the issue is, fix it, and then have to push it in. But if we have quality gates, you'll be able to detect that, oh, this code that this person is pushing is actually buggy, right? And then we fix it at that point before it actually gets into the existing code base. And you have to do this every time, at every point, you are trying to add new code into existing ones. And then there are pre-commit hooks. Pre-commit hooks can also help you to the difference though, they both do the same thing. They're both gates, but using tools like GitHub Actions and Jenkins actually runs this linting and formatting and stuff on GitHub or whatever platform where you are hosting it. But pre-commit hooks would do the same thing on the developer's machine. So what it actually means is I'll be able to catch those bugs. I'll be able to catch those failure points even before the developer commits whatever he has done to Git. And I believe we are developers here, so we can understand, we all know what Git is. So pre-commit hooks would catch those bugs, would find those things out even before that commit is created. And then eventually when that commit is created and is pushed to GitHub or wherever it is the CI runs, you find that there are probably no other issues to handle. And then quality monitoring. It's not a one-time thing. It's something you do, from time to time. And we can use tools like SonarQube SonarQube, by the way, is a static application security testing tool that allows you to analyze your code base against gamut of pre-existing or common well-known issues that can exist in a code base. So regardless of the language you're writing, they have like a collection of vulnerabilities or situations that are not optimal that you shouldn't typically have in your code base. So when you set up SonarQube servers and run your QA/QC scans against your code, you'll be able to find out these security issues even before um, it hits your production. And it's also a very nice idea to do these things before your quality gates, right, or at your quality gate. So this is part of the checks you would typically make to ensure that the code that you're adding to the already existing code meets certain security thresholds. Also, there is dynamic application security testing, which you can do with OWASP app. And the difference between static and dynamic is SonarQube, being a static tool, would scan the code at rest. Basically, it's not going to run your code. It's going to look at just the lines that you've written and try to match it against certain known patterns, like I've said, and make decisions based on what it can see on your code and what it knows. Why dynamic application security testing is going to actually test your code while it's running. So you basically have to build and run that code, and then you point Zap to it, and then Zap would interact with the application to interact with the application while it's live. Or well, not necessarily live, as far to the users, but the testing live in the test environment, and then it would try to find security issues on why the code runs, and this will kind of basically mimic the regular user that you have in your application. And then definition of done should always include testing. I cannot stress this enough. Definition of done, for you to say a feature is done and completely done, there should be testing somewhere along the line. And then encourage peer reviews that focus on maintainability and not just functionality. So I see a lot of engineers today. They say if it works, there is no need to fix it. But well, I don't think that's. I mean, there is a cost to fixing issues, to fixing bugs. I mean, it's the engineers, it's man hour, right? So it's being paid for somehow, and of course, it can actually delay your speed of delivery. But if you're after just shipping stuff and you're not properly testing and organizing it, then you will lose more, because when it fails, it's going to cause a whole lot of issues. So peer reviews should focus on maintainability and not just functionality. And finally, I would like to leave us with these little quotes. Quality is a culture, not a department. So yeah, we have QA/QC engineers, but and yeah, they do have their job descriptions and things they are supposed to do, but we all can um get our hands dirty in making sure that the quality of code we put out there is up to standard. It's enterprise level. It helps everyone on the team. I mean, if the team does good, everyone on the team does good, right? But if even no matter how good you are, if your team is not good, if your team is not perceived as good, no one is going to value you. And that's why we should all get our hands dirty to make sure that the team moves as one and deliver quality products. That brings me to the end of my presentation, and I will be glad to take any questions. Once again, that's my portfolio there. You can scan the QR code if you're interested in getting to know me better.
Thank you so much. Thank God for that insightful session. So, like he said, if you have any questions for him, now is the time to ask. You can use the Q&A section for your questions. So, is there anything you would like to ask? Thank God. Or is there any scenario you would want to pose to him and, clarify anything, any questions or anything that you have? Essentially, this is time for Q&A. So, the floor is yours. I want to know that we actually have people active here. So if you're listening, whether you have a question or not, can you drop me a hi in the chat box so that I know we have people active? Okay, hi, Azizat. Thank you. Hi, hi, hi. So what I get is that we have people here, but thank God your session was so clear that they don't have any questions. So
I hope so.
yes, that's what I'm getting. But I think we just, or was it hard? No, I doubt it. Was it hard? You guys, that's it. Was it hard that you don't know where to start asking from? Or was it so clear that you don't have any questions? I want to believe that it was clear. Um, but we'll still leave the floor open. Let's see if people are maybe trying to gather their thoughts and put their questions together. Oh, I see. Kende says that most of the concepts are quite new to his ears. Um, so when you say they are new, okay, so are you saying that they're new, so you have to do your research, or I don't know. Okay, they would like to read up with the slides. That's fine. We would send the slides across to you after. That's not a problem. I understand that in this particular session, it's not just old school learners. So there are people that are aspiring engineers too. So people that are already learning, some people that have learned, and some people that are aspiring. So it's a mix of multitude. So I guess that because of that, some of the things that were said, some people are not quite aware of it, right? So we are going to send the slides across after the session. Not immediately after, but we would send it later on, if that's all right. All right, now I see that we don't have any questions, and I don't want to keep people around. If we don't have anything that is keeping us here, right? You're welcome. But in the spirit of Valentine's, tomorrow is Valentine's Day. Oh, okay. Community has dropped it already. That's perfect. Thank you. In the spirit of Valentine's, we have a gift for everyone here, whether you're an old school learner or you have someone that you want to learn at old school, or you're not an old school learner and you would like to learn, we have a code for you um, from us at old school and at start. So you have to use the start code, the start 26 code when applying. Once you use this code, you're going to get 20% off your application fee. So this is for everyone. And if you're an old school learner and you want to refer someone, you can also use your earn privileges. So if you go to the portal at oldschoolafrica.com, you see the earn section. Once you click on it, you see your code. And at that point, you can give your code, your reference code or your earn code to someone that you know and love, and they can use that code to apply. So you would also get your own gifts from Old School, your monetary gift from Old School, while the Start 26 code is for people that want to apply freshly and they want 20% of the application fee. So at this point, I'm going to say good
Hi, Amara.
night.
Hi, Amara.
Okay. Hi, Tabby. Go ahead.
There's a question in the chat.
Ah, okay. Oh, okay. Sorry, I missed that. Thank you. Thank God we have a question. So the question says, as an aspiring cloud engineer, do we still have to focus on code testing as most of what we do is build architecture? I want to be sure, please. Thanks.
Yeah, I have this philosophy of being aware of whatever happens in the entirety of the system. So I'm not just a cloud engineer because, like, I don't say I'm just a cloud engineer and then I shouldn't know what design entails or what front end or back end development entails. Even if you're not so deep into cloud, into the other aspects of building the system, I urge you to have an idea of what's going on. There are situations where, um, for instance, you've built the architecture, the cloud architecture, you deploy the infrastructures and all of that, and then you deploy the code, and it's not running. You're wondering what's going on. Is it that I did not configure stuff right? Is it that the code is bad? Now, if you do not have any knowledge at all of what that code is or what it's doing, you find it will be tougher for you to debug and make progress. So while you are aspiring to be a cloud engineer, if you have an opportunity to learn about backend development, you don't have to go very deep. Just know the basics, the high level stuff, the way they do things, and it will really help you. It will help you go a long way. That's what I have to say to you as regards that. You don't have to focus on code testing, like, to be more direct or have an idea.
All right, thank you. Thank God. So I think that I can go ahead and end this right now, right? Or do we still have anybody else that has a question? So that's I don't miss that. I guess not. So once again, enjoy the rest of your day or your evening, and happy Valentine's from us at Old School. Bye everyone.